Any questions on the homework so far? Now, what we're doing today is partial fraction decomposition. Now, we've talked about fractions and rational expressions before. And most of what we've talked about is that we take a fraction, say 6 over x plus 2, and add to it, say 2x over x minus 4. And we went through the whole process of adding these two fractions together. We would get the denominators to be the same, so for the one on the right, we would multiply by x plus 2 over x plus 2. The one on the left, we'd multiply by x minus 4 over x minus 4, giving us a common denominator of x plus 2 times x minus 4. And then we'd multiply the numerators. From here, we would add like terms. Also, we have 2x squared plus 10x minus 24 over x plus 2 times x minus 4. And this would be it here. And we would go through putting it together. Now, what we're going to be doing today is going from our combined back into our individual terms. We're going backwards from it. So, we consider the rational expressions f of x over g of x, where f of x and g of x are polynomials with real coefficients, and g of x is not 0, because we can't divide by 0. The degree of f of x is less than the degree of g of x. Step 1, we factor g of x completely. We factor the denominators completely as we get. ax squared plus bx plus c to the n that are not factorable further. If they're not factorable, we leave them as is, but try to get them down as simplified as we can. Then we set it up using a, b, and c as linear factors, and quadratic factors, have bx plus c, and so on. Really, whatever the degree of the bottom inside the parentheses, even if we do have a power of 2, the top is going to be 1 less than it. So since inside each one of these parentheses for this top set, the degree is 1, the degree of the top has to be 0. So we just have a, b, c. For when here, the degree of each one of these parentheses is 2, the degree of the top is 1, so we'll have an x, and so on and so forth. And then we write it and go through these steps here. Now, the first thing we're going to look at before we actually do partial fraction decomposition is breaking it down. So here we have 4x minus 15 over 2x plus 3 times x minus 2. We're going to actually set this up with the partial fraction decomposition. Now, the number of fractions that we have, or is going to be possible to break it up into, is going to be dependent on the number of number of factors in the bottom of the fraction. So if we look at this one here, well, I have 2x plus 3. I have 1x minus 2. So we have a total of 2 factors. So the number of possible fractions that this rational expression can be broken up into is 2. Questions on this so far? Now we write each one underneath it. So the first one we have is 2x plus 3. And the other one we have is x minus 2. Now if it had been 2x plus 3 squared, so this is just, we had it squared, well, we would actually need another term. All right, I'll just erase this for here now. Because we'd add a third one in, we'd also have 2x plus 3 squared, and then x minus 2. So since we have 2 of them, we need them both. We need 2x plus 3 and then 2x plus 3 squared. If we had it cubed, we'd have 2x plus 3, 2x plus 3 squared, and then 2x plus 3 cubed. We just keep adding them on for each power that we have. But since we don't have the square, We don't add it in there. We just have these two. Questions on this so far? Now the degree of each of these here in the denominator, 2x plus 3 and x minus 2, the degree is 1. Because the biggest exponent attached to each variable is 1. So the degree of the top is less than that, so it's 0. We don't have a variable. So I will call this A and this B. In the kind of steps to how to solve it, they said a sub n, or a sub 1, a sub 2. I just continue alphabetically. So I start with A, go B, C, D, E, and continue on. That's it. That's all I have to do is set this up. We're not actually going to solve this here. We're just setting these up. Any questions on how we set this up? Let's look at B. Now, in B's case, is the denominator factored? Well, no. The denominator is not factored, so we need to factor it. And looking at x cubed plus 6x squared plus 9x, each term in the denominator does have a greatest common factor of x. So we can factor an x out first, leaving us with x squared plus 6x plus 9. Now again at this point, x squared plus 6x plus 9 is factorable. Since the third term here is positive, our signs are the same and match the sign of the middle term. So we'd have plus and plus. Factors of the first term, x squared, well, the only factors are x and x. And the factors of 9 that we want are 3 and 3. So now the denominator is completely factored. And if we wanted to, we can consider it to be the same as x times x plus 3 squared. Questions on how we got to this point here? Well, now we need to see how many factors or fractions we will have. Well, how many factors do we have in the denominator? 3, yes? So we will have 1, 2, 3 fractions. Now the denominator of the first we can call x, because that's one of our factors. One of our other factors is x plus 3. Now what's our last factor going to be? X plus 3 squared. Now what goes on top? Well, the first one's going to be A, the next one is B, and the last one we can call C. Now none of them have an x because, well, the degree of each is 1. Even though the last one is x plus 3 squared, the degree inside the parentheses is 1, so we don't need anything else with it. And that's all we need to do to set this up. Any questions on any of this here? We feel pretty good about setting these up. Yep. Set up the partial fraction decomposition, so we just want to set it up. So again, Before we solve it, we're going to do one more setup, and then we're actually going to start solving these. Now with this one here, again, the numerator doesn't make too big of a difference. 2x cubed minus 3x plus 4. Now the denominator in this case, x cubed plus 4, is not completely factored. So the first thing we can look at is greatest common factor, and there is a greatest common factor of x that we can factor out. So we can factor an x out of x cubed, giving us x squared. And if we factor an x out of plus 4x, we have plus 4. Now the question is, can we factor x squared plus 4? Well, no. If it was x squared minus 4, it would be a difference of perfect squares, and we can factor it. Now, x squared plus 4 technically can factor, but its factors, you don't need to write this down, would be x plus 2i and x minus 2i, since they're not real factors. 2i and negative 2i are not real. We don't include them. So this is completely factored. Now looking at this here, how many factors do we have in the denominator? Well, we have 2, yes? So that means we'll have how many fractions? We will have 2. The first denominator would be x, and the second one will be x squared plus 4. Now for our first one, with x, the degree is 1, so it'll be the same as what we've done before. We'll call it a. However, what's the degree of the denominator of our second fraction? It is 2, yes? Which means the degree of the top isn't going to be 0 like the first one. It's now going to be 1. So what we'll say is that we have bx. But that's not all. We will also have plus c. bx plus c. So we'll have the term with x and then our constant term, our number. And this is the complete setup. Does this make sense? And the reason that we're doing this is we need to take into account every possible value of a, b, c here. Mrs.
Strope, call the office. Mrs. Strope, call the office.
Because like the example we had at the beginning that I started out with talking about, we had one fraction where it was just a number and the other fraction had just a number and x. It could be that the second fraction here has a number with x and a number also, so it could be 2x plus 2, or it could be just 2x, or we could have just 2. We have any of these possible combinations, so we add the bx plus c to take that into account. Any questions on how we set this up? Let's look at the other setup, part B. 3x squared plus 8x plus 14 over x squared plus 2x plus 5 squared. Now looking at this one here, the question is, can we factor x squared plus 2x plus 5? Well, most likely not. If we did want to check and make sure, we can use kind of a check I found for quadratics, our square root of b squared minus 4ac. If this does give us a nice number, then it is factorable. And for us, this would be the square root of 2 squared minus 4 times 1 times 5. And it doesn't matter which calculator we plug it in. We can go second square root of 2 squared minus 4 times 1 times 5. Enter. Tells us it's domain error. It's just telling us that the number inside the radical is negative, and the 30xs will not take the square root of a negative. Or, in other words, x squared plus 2x plus 5 is not factorable. So what that means for us is that we can go on and set up our fractions. Well, how many factors do we have? 2. Because of the square, we have 2 of them. So that means we'll have 2 fractions. Now the denominator for the first is going to be x squared plus 2x plus 5. The second one's going to be x squared plus 2x plus 5 squared. Now the numerator of the first exponent, because the degree is 2, the degree of the top has to be 1. So we could say ax plus b. What do we think we'll say that what's going to go on top of the second one's going to be? Bx plus b. So with the lettering, I just continue on. Since we used A and B in the first one, I'm going to go to C and then D, E, then F, and so on. Continuing from there. That's it so far. Any questions on how we set this up? We good with this here? We ready to actually start solving these? Partial fraction decomposition. Find the partial fraction decomposition of this here. Now, I'm going to be perfectly honest with y'all. Out of everything, I really do enjoy partial fraction decomposition. Because once we see how they work, it's actually, there's nothing really too overly complicated with it, with finding these values. So the first thing we're going to look at with this is making sure the denominator is factored. Well, here the denominator is factored, yes? So we can set up our fractions. Now, because we have 2 factors in the bottom of the fraction, we will have 2 fractions. The first denominator will be 2x plus 3. The other denominator is going to be x minus 2. Now, on top, we will have a, and then we will have b. Now, we don't do ax or bx because the degree of the bottom of both of these fractions are 1, so the degree of the top should be 0. We shouldn't have an x. And this so far is the same thing we've done. We've set it up. Now, the first step in actually solving this is to get rid of the fractions so that we just have a linear or polynomial expression. And to do that, well, I'm going to multiply everything by the bottom of our starting fraction. So we'll multiply everything by 2x plus 3 and x minus 2. Now the one on the far left, the 2x plus 3, 2x plus 3 cancel. X minus 2, x minus 2 cancel. Telling us that we have 4x minus 15 is equal to our first fraction on the right-hand side, the 2x plus 3 and 2x plus 3 cancels, leaving us with a times x minus 2. Plus, in our other fraction, the x minus 2 and x minus 2 cancel, leaving us with b times 2x plus 3. Any questions on how we got to this point here? Now at this point we do need to distribute the right-hand side. So we can do a times x and a times negative 2, giving us ax minus 2a. Plus, we distribute the b. b times 2x is 2bx. And 2 times 3 is plus, or b times 3 is plus 3b. Now I'm going to rearrange the right-hand side because we have 4x minus 15 is equal to, I'm going to put the x's together. ax plus 2bx. And we also have negative 2a plus 3b. Any questions on how we got to this point here? Now most of this, and especially this next step, is to help y'all see how this is going to work. It's that I'm going to factor the x out of these here. Now if I factor the x away from a, we're just left with a. If we factor the x from 2bx, we're left with 2b. Now normally we put the x in front. I want to put it behind it just so we can see this. But looking at the left-hand side, we do have two terms. We have a term with x and we have a constant term, yes? On the right-hand side, realistically we have two terms. We have this term with x and then this kind of whole term with a number. So really for it to kind of match up, our 4x is matching up with our a plus 2b times x. Use a different color. Our negative 15 is matching up with our negative 2a plus 3b. And so what this is telling us, and kind of using these two together, is that, well, we can say 4x, I want to move it a little bit further to the left, use green. 4x is equal to our a plus 2b times x. Well, at this point, we're not really worried about x. We're wanting to find the values of a and b so we can plug them back in. So with this here, we're really saying 4 is equal to a plus 2b. Questions on this here? Now what we're also saying is that negative 15 is equal to negative 2a plus 3b. Any questions on this here? Because really, if these are going to be the same, our negative 2a plus 3b should give us negative 15. Our a plus 2b, since it's in front of the x, should give us 4. The a plus 2b should add together to be 4. The negative 2a plus 3b should combine to give us negative 15. So the two sides are the same. So we get these two here. Now we just need to solve for a and b, which we go back to our systems of equations. Now we can do elimination, we can do substitution. Well, looking at these two here, I would eliminate a first because the green equation, the number in front of a is 1, the blue equation has a as 2. So what we can do is multiply this equation by 2 and use elimination. And if we do this multiplication, 2 times 4 is 8. 2 times A is 2A. 2 times 2B is plus 4B. Now we can put this equation under the other. A equals 2A plus 4B. Now would we add or subtract these? So we can look at 2A, negative 2A, and 2A. If we subtract negative 2A minus 2A, would be not 0, it would be negative 4. So we would need to add. Because if the signs are opposite, we add. Because negative 2 plus 2 is the same as 2 minus 2, which is indeed 0. Okay. Now, negative 15 plus 8, 8 minus 15 is negative 7. 3b plus 4b is 7b. At this point here, we can solve for b by dividing both sides by 7, telling us that b is negative 1. Any questions on how we found the value of b? Now we just need to pick one of the equations to plug it back into. It doesn't matter which one we pick. Highlighter. Let's go with light blue. Well, okay, I said light blue. There we go. We could pick this equation here. I could use this equation here. Or we can use this one here. It doesn't matter which one we pick. Any one of these three would work. I'm going to pick the first one that I highlighted. R4 equals A plus 2B. Part of the reason I'm picking it is, well, it does have A by itself. So 4 is equal to A plus 2B. So 4 is equal to A plus 2 times negative 1. 2 times negative 1 is negative 2. At this point here, we can add 2 to both sides, telling us A is equal to 6. Any questions on how we found A and B? We ready to write the final answer? Because even though in a lot of Algebra 2, where we did it, we found the values of the variables, we found what we're solving for, that was the final answer. Well, again, we're trying to find this partial fraction decomposition, what it is. So what we're going to do is plug back in our values of A and B in their respective positions. So A was 6, B is negative 1. And that there is the final answer. Now there is an alternate version of this answer. And that's just dealing with the fact that B is negative 1. If I don't want to write it as plus negative 1 over x minus 2. I can just move the negative in front of it and say that they're being subtracted. That's it. So this here is the final answer, or we can say plus or negative 1. Either one works. Questions on any of this here? Are you ready for the next one? Now, luckily for us, they already have the denominator factored. 3x plus 1 and x plus 4. So the top of the first fraction is going to be a. The top of the second fraction is b. Now at this point here, we're going to multiply through by our 3x plus 1 and x plus 4. These will cancel with both of these here. 3x plus 1 and 3x plus 1 will cancel. X plus 4 and x plus 4 will cancel, leaving us with negative x plus 18 is equal to a times x plus 4 plus b times 3x plus 1. Now at this point here, we're going to distribute the a and distribute the b. A times x is ax. A times 4 is 4a. B times 3x is 3bx. Plus 1 times b is b. Any questions on any of this here? Now again, on the first one, we rewrote this several times just to see how they all lined up, yes? Now when I do these, I do them a little bit different. I don't continue to rewrite it, manipulate it, and go from there. Because looking at this here, I know that the negative x is going to line up with our ax and 3bx, yes? Or more specifically, the number in front of it, negative 1, is going to equal, term in front of ax here is just a, positive. Term in front of this here is plus 3b. I gathered those together. Because we could rewrite it, as we did before, as ax plus 3bx. And then factor the x out. Because you don't have to write this, because we could say ax plus 3bx. And then say that we have a plus 3b times x, and then connect the a plus 3b to our negative 1. Or if we know that those ax and 3bx are going to connect together, we don't need the x because they are in common. We can go straight to this here. The same thing is true with our 18, because the 18 is going to connect to our 4a and b. So we have 18 is equal to 4a plus b. Now the question is, do we want to solve for a or b first? Or which one do we want to eliminate first? I'll just say a. And to do that, we'll need to get the a's to be the same. Since this one is 1, the other one is 4, I'll have to multiply the equation in green by 4 on both sides. 4 times negative 1 is negative 4. 4 times a is 4a. plus 4 times 3b is 12b. And at this point here, we can put it underneath the other equation. Negative 4 is equal to 4a plus 3b. Let's pick this color. Now, since the values of a have the same sign, we will subtract, because 4a minus 4a, 4 minus 4 is 0. 12, thank you. I was wondering why. Had some confused faces, that's why. Wrote the wrong number. So these will still cancel. Now, 18 minus negative 4. Well, the negative and negative makes a plus. 18 plus 4 is 22. B minus 12b is negative 11b. Since we have b by itself, we can divide both sides by negative 11, telling us b is negative 2. Now we just need to solve for a. I can pick the first equation. Negative 1 is equal to a plus 3b. We can plug the value of b in. Negative 2 minus that negative 1 is equal to a minus 6. Add 6 to both sides, telling us a is 5. And that brings us back to the top. So a is 5. So 5 over 3x plus 1 plus negative 2 over x plus 4. What do we think of these here? We good with these here? So we don't quite have time for these last two here, and especially this one here, but that's not a big deal. I put these in as extra ones to look at because, again, I find this very fascinating, very interesting, and I actually really enjoy these because is complexity to them, but once we see how they work, there's not a whole lot to them. Now, some of the more quote-unquote complex ones where we end up getting fractions as ax plus b plus cx plus d plus e plus f, and we can have multiple, and we can continue on, or we could have quadratics, ax squared plus bx plus c, and working these together to find out what it is. And it works out sometimes that a, b, c, d, e, or f, some of these could be 0. Or some of them, when we work them out, do end up being by themselves, or we only have a number equal to f. It's the only one that has that term. So it's just that number. So some of them work out nicer than others. But all the ones on the homework are going to be like the two we did. Questions on any of these here? So that is really it with partial fraction decomposition. That's all we're going to do with it. Even though there is so much more we can do, that's all we're going to cover with it.